welcome Steve to the afternoon talk.
Slideshow move. There you go. Just take a second.
Hi. Welcome to this talk. As you said, I'm Steve Griffing. I'm going to be talking about some work I did the last spring doing some categorization of unmanned systems and working through the DoD's RMF process for these systems and why you would make certain decisions about what security controls to use for unmanned systems. Who I am, I've done a lot of work in cyber and OT. I'm a licensed professional engineer and have several certifications in the field. Most of my experience has been in the DoD, specifically in the Navy, but none of this stuff that I am going to be speaking about represents the opinion of the U.S. government. This is all my opinions, and I'll make sure that's clear. Right. Anyone who's done an authorization or accreditation process will probably be familiar with the 7 steps of the risk management framework. We're going to be going over the first 3. The preparing, the categorizing, and selecting. That's preparing all the information. That's the newest thing that they added to the latest iteration of the NIST framework. It used to be just categorize, select, implement, assess, authorize. But preparing is a significant chunk of work, and especially when not everyone wants to play in the same set of rules or play nice with each other. Makes it a little harder. And then the other constraint we have here is that we're not talking traditional IT systems. We've heard a little bit earlier today the OT playbooks and the criticality of operational technology and the differences. But what it comes down to is the OT systems are not designed to manipulate data. They use data to manipulate their environment and to operate in their environment. And that is why that's what makes them unique, but it also changes our priorities. For a control system, things like safety come into the forefront because you're dealing with people and equipment that have to operate in hostile environments and around people that can be hurt by it. And you're unlike in an office environment with a computer, if I crash it, you can just rebuild it. No harm, no foul. In the real world, we're dealing with hardware that can break. We're dealing with people that can get hurt. And our primary 2 references are going to be the NIST 882. The second revision is enforced. The 3rd revision to that standard is currently in draft, and it will be released soon, hopefully. And then the other primary one is the ISA 62443 series, which is the industrial equivalent to the government NIST publication. Most times you think about drones and unmanned systems, you're usually thinking helicopters, quadcopters, airplanes. Well, I was not working with airplanes. I was working with boats. And things like this Sail Drone Explorer, which you've seen it in the news a couple times. And just this past week, there was some video of one in the middle of Ivan, because that's what they're designed for, hunting and getting METOC data, weather data from inhospitable areas where you don't want to sail your own pleasure craft into, but you can get really good information. The DoD decided to use some, and that's why I was tasked with doing a risk management framework on these. It's a awesome piece of tech, but never been in the government service before. So coming from a very clean slate. And then it's a very smart, very robust piece of tech. But it is ultimately a control system, not an IT computer. And that's where we're going to get into the categorization. So, step one, prepare. The biggest challenge with these, anyone guess? Maybe read it off the screen. Intellectual property. Who owns it? Who owns the command and control? And who owns anything that it picks up in its environment? And those are different pieces of the puzzle. And so making sure that you have all of that documented in writing beforehand is vital. We've got those locks out there, and the first thing they tell you about picking locks is you either have to own it yourself or have written permission from the person who does own it. Same with this stuff. If you don't have written permission, it's not yours. And you can't even defend it. So, and if you want to get all the necessary documentation, the network diagrams, the engineering diagrams, the code, and all that you need to properly defend it, you first have to get that permission. And working through those contracts is why we hire lawyers. So know a good lawyer, work with the teams, know who to contact, contacting their C-suite, and then working downward into the technical subject matter experts who actually know what they're talking about and what questions to ask. Gets you where you can get all of those things. And then just remind them of the conditions of the contract they signed, and usually that helps bring them to the table. And one of the biggest most overlooked people when you're working with this is the industrial engineers. They're not IT guys. They don't think like IT guys. They didn't go to school for computer science or cybersecurity. They went to school for robotics. So they spent more time studying physics and mechanics than they did coding. So they're going to think differently than you are. But without their help, you're not going to get your task done. And That's where, and they can give you vital information, that those process and instrumentation diagrams that actually tell you what the robot is doing and what controls what. And also, if you're halfway around the world, making meetings, even virtual meetings, is challenging. All right, now, getting into the actual categorization. The reason why you want to think of this as a SCADA, which is a subset of OT, is because the architecture. You have the architecture of a SCADA taken right from the NIST pub, their standard thing. Okay, you've got a control center over a wide area network to a set of nodes, and each node doing local control there. Look at how you control a drone. You've got a control center over a wide area network to a fleet of ships, each one doing autonomous control and autonomous operations on their own with supervisory control. It's basically the exact same architecture. And therefore, it is a very good place to start when you are trying to secure it. Because a lot of the same challenges you're going to have. You're not going to have easy access to the endpoints. You're not going to have a standard IT protocols. You might not, but more likely you're going to be dealing with real-time protocols, real-time interfaces, and you always have to deal with the environment. All right, so that is why we're categorizing it as a SCADA. But nobody puts a drone anywhere just for its own sake. It will have a payload. And that is typically a standard. It looks a lot more like your IT database or an IT system. So you're going to have to secure that like an IT system. And you can't just glob it into one system. You have to separate and find that distinction between the bus and the payload. There should be a hard differentiation so that one doesn't share information with the other for both security and just organization reasons. Now, then let's get into that that bus, because a lot of other people have talked about how to secure that payload. Here we have our classic Purdue reference architecture, which is going to work. It's designed for a manufacturing plant, but it kind of does apply here because you still have that layer 0, which would be your rudder and propeller, pushing it through the water. Your layer 1, that's your motor controllers. And layer 2, supervisory control on the local to the craft. And then you have a large gap to your supervisory control, where you have controlling multiple systems at the same time. I like the way the ISA does it better than NIST. ISA breaks it down into zones and conduits, where each zone each vessel is going to be its own zone. And each of those zones is connected with a secured conduit, a secured path to the other parts. And by breaking it into that model, you have a lot more finite and a lot more discrete control, because one drone in one area might have a different risk profile than one in another area. The risks to a drone going into a hurricane are different from the risks of a drone sitting in a contested strait. As you can see, both recent news photos, that top one is a sail drone in Ian, doing 35 knots under sail in the middle of a hurricane. Second one, another sail drone getting investigated by our friends in the Middle East. So very different risk profile. The physical security of that second sail drone had to be augmented. And you can check the news for that. The other one, sorry, I just put a random citation in the middle of my slide. But these risk profiles are different. So being able to categorize them differently with different zones is important. And that. So that is any questions on why you would use this and how to categorize drones, and like these things, while I was talking about surface vessels, it's applicable with any, whether it's your little drone or a big fleet, and it's, so questions, comments? Yes. Yep.
You mentioned earlier in the session about how these drones would have a payload associated with them. So how is that payload categorized in relation to the drone categorization that we covered?
Okay. Yeah. So the payload is going to be. It depends on what the payload is, and that's depending on what the owner or client of that drone wants. Like these drones were designed to pick up a lot of weather information. So a whole bunch of weather sensors and that type of stuff. And it's going to process it, send it back, but because it's an IT system, you're going to look at it from confidentiality, integrity, availability. Whereas on the bus side, on the actual vessel, you're worried about that safety, availability, all of much higher than your confidentiality. And that's why, because there's different risk profiles, you have to deal with them separately. Okay. Yes. First you, then. Yeah. Right.
So, what are some particular challenges you see with implementing these changes on these mobile systems?
Yeah, good question. Your typical SCADA is a fixed environment, either local or even broad, but your challenges are going to be more in your transmission path. So here we've got a radio-based off satellites transmission path, and as long as you're able to maintain that transmission, it's going to be similar to the other challenges of it's just infrastructure. that it's a pass-through. But you just have to be mindful of the differences in it. Yes?
What is the best way to learn more about it?
Well, talk to an expert, but really you need to get a firm understanding of the engineering side and then an understanding of the cyber side. They're two very different fields, but talking to organizations like the International Society of Automation and getting the hard engineering training, and then going to someone like SANS and getting the cyber, and then you can bring them together. But trying to just start there, you've got too much foundational information on both sides that you can't just start without getting a foundation on first. Yep.
All right, we've got 2 gifts to give away. Do you have any questions for our audience?
Well, let's see. Question for my audience. What are the 2 primary resources and standards that I touched on? Yep, good job. And what is the biggest challenge with trying to get information about a system? Yep. There you go. All right.
All right, I think we have time for maybe one more question. Any more questions?
Sure.
How long did the RMF process take for that specific project?
For the part that I did not get all the way through authorization. I spent about 4 months working through those 3 steps. So,
And then the agency is going to take about 2 years to implement that.
so
All right,
yeah.
folks.